Have you ever wondered how the mysteries of the universe could be unlocked? Enter the surreal realm of quantum computing. In this mind-boggling domain, tiny particles hold immense power. Here, bits evolve into qubits, and data is not just zeros or ones, it can be both at once. Imagine solving problems that would take classical computers billions of years in just a fraction of a second. What if we could simulate every single particle in a drug, revolutionizing medicine and saving countless lives, or crack codes that are deemed unbreakable? It might sound like alien technology straight from a science fiction movie, but my friends, quantum computers are all too real.
These things exist. We're not talking science fiction. This is just one of several different kinds of quantum computers. Why does it look like a chandelier? These are cooling pipes. The quantum computer computes on an object about the size of a quarter. The whole assembly is like the size of a suitcase. Everything else is cooling pipes. Why? Because the slightest vibration, somebody sneezes in another room, a car backfires, and it could upset the calculation. Errors build up. And this is one of the reasons why this technology is not yet ready for prime time. But about 2 or 3 years ago, 2 groups created quantum supremacy. Quantum supremacy is the point at which a quantum computer exceeds the power of a digital computer. And that was reached by 2 groups, one in China and the other one, Google. Quantum supremacy has been attained for certain discrete calculations. Now, an all-purpose quantum computer that you can program does not yet exist. But that's the race. There's a race now between the Chinese, Google, IBM. There's a race between all the major players of Silicon Valley, realizing that this is, quote, the next big thing.
So what's the big deal with quantum computers? Let's start by peeling back the layers. Traditional computers use bits as the basic unit of data, which can be a 0 or a 1. But quantum computers use quantum bits or qubits. Here's where things get strange. A qubit can be both a 0 and a 1 at the same time, thanks to a quantum phenomenon called superposition. Now, add entanglement to the mix, another bizarre quantum trait. When qubits are entangled, the information in one instantaneously influences the other, no matter the distance apart. It's like magic, but it's real science. Imagine you're solving a maze. A traditional computer tries every path one after the other, but a quantum computer? It can explore all paths at once. It's like having millions of well-coordinated copies of yourself working on the same problem. Hold on, because it's not just about speed. Quantum computers could simulate nature at the atomic level. This means we could discover new materials or even unlock the secrets of complex diseases and expedite the search for cures. But here's the catch. Building a practical quantum computer is incredibly challenging. They're extremely sensitive to their environment and need to be isolated and cooled to near absolute zero. And so, the race is on. Tech giants and startups are pouring in resources to be the first to harness the true power of quantum computing. As we teeter on the brink of a quantum revolution, who will emerge victorious in this high-stakes global race? And more importantly, how will this technology reshape the fabric of our reality?
How do the Chinese do it? The Chinese do it not with electricity, not with electrons, but with light beams. Light beams are polarized, like when you take sunglasses. Sunglasses have striations on them, let's say vertical striations, so that the only light that enters your eye vibrates up and down. Light that vibrates to the side does not enter your sunglass, and that's how sunglasses work. Well, that can be used to make a transistor, an optical transistor. And with an optical transistor, you can make a quantum computer. This is the Chinese quantum computer. It doesn't look like a chandelier. That's what the American version looks like. This is the Chinese version. What you see are mirrors. A mirror and a piece of glass can be a beam splitter. And what is a transistor? A transistor is a way, in some sense, to control the beams of electrons. Here, these are beams of light. And so the leaders in this race are one, the Chinese, and then in America, we have Google, IBM, Microsoft, everybody. Honeywell, you name it, everybody's jumping in the game. What's at stake? The world economy. The world economy today depends upon digital computers. They will eventually become obsolete. When, we can't say for sure, but Moore's law will eventually flatten out. It's beginning to flatten out already. You can see it. At Christmas time, Christmas presents are not twice as powerful as they were the previous Christmas. Now let me ask you a question. Would you upgrade knowing that your computers are just as powerful as they were the previous Christmas? This could send shockwaves through the world economy, realizing that computer power is stagnating in the digital era. So how will we communicate with a quantum computer? The quantum computer will probably be in the cloud. They probably need a lot of cooling system to bring it down near absolute zero. But you will communicate using probably a digital access to a computer, quantum computer in the cloud. This interface could be in your wristwatch, it could be in your earrings, or it could be in your contact lens. This is internet contact lenses where you can access the internet by blinking. If the internet is in your contact lens, communicating with a quantum computer in the cloud, who will buy these things? College students studying for final examinations will be among the first to buy internet contact lenses. These contact lenses will also identify people's identity. Just by looking at them, you'll know who they are, what language they speak. It'll translate these languages. Very useful. And these things actually already exist. One contact lens gives you a golf score, for example. Eventually, you'll download the entire internet on your contact lenses or your wristwatch or earrings or whatever.
As we cast our gaze upon the horizon, let's explore the boundless ocean of possibilities that quantum computing is set to unveil. This technology doesn't just promise to speed things up. It's poised to revolutionize the way we think, innovate, and interact with the fabric of reality. Let's talk about the unparalleled synergy between quantum computing and artificial intelligence. The power of qubits can propel AI to realms we've only dreamt of. Imagine AI systems that don't just learn but evolve. Think of self-driving cars that adapt to every driver's habit, or AI doctors that can diagnose and design custom medical treatments in a heartbeat. And we're just getting started. The pharmaceutical industry could be turned on its head. Quantum computers can simulate molecular interactions at an unprecedented scale, potentially leading to the discovery of new drugs and treatments for age-old ailments. On a grander canvas, we could decipher the cryptic mysteries of our cosmos. Quantum computers can help us simulate the subatomic particles and forces at work in the universe. What really happens inside a black hole? How did the intricate tapestry of galaxies form? The answers could be within our grasp. On the economic front, quantum computing could optimize global financial models, make supply chains more efficient, and even solve complex logistical challenges which are currently impossible to tackle using classical computers. And what about security in the quantum age? The same technology that can crack today's encryption can also create virtually unbreakable codes. Imagine a digital fortress that evolves to defend itself. But as with all great leaps, there are crucial questions and challenges. What ethical considerations must be taken into account as AI leaps forward? How do we ensure that this potent combination of AI and quantum computing is harnessed for the greater good? As we stand at the cusp of a new era, it is not just the technology that needs to evolve, but our wisdom and foresight. We are like pioneers stepping onto an alien world, with knowledge as our compass. Quantum computing beckons us to boldly reimagine the very nature of innovation and problem-solving. It challenges us to ask questions we never thought possible. So, as we delve into this new age, let us ask ourselves, are we ready to embrace the quantum revolution and the boundless possibilities it holds? What will we create? And more importantly, who will we become?
The greatest consumer of quantum technology is Mother Nature. You go outside, you see photosynthesis, you see leaves, trees, agriculture, you see the variations of life on the earth. All of it as a benefit from the quantum theory. Nowhere do you see zeros and ones, zeros and ones, zeros and ones. Photosynthesis is a quantum process, taking light, photons from the sun, combining it with carbon dioxide and creating oxygen and sugars. This is why you can breathe. This is why humans can exist. We are benefits of a quantum process that is beyond the capabilities of our most advanced chemistry. In other words, we have to follow Mother Nature.